Okay, so we look at this part. As you can see here, we have a stationary point. So first of all, of course, I think you should know what is stationary point. It's either the maximum point or the minimum point. They are called stationary point. Okay, so beside that, a point of inflection is also a stationary point. So point of inflection is like this or like that. Okay, so let us look at more information. A stationary point on a curve occurs when dy over dx equal to 0. So you know dy over dx is basically the gradient. So as you can see here, the gradient of this maximum point is a horizontal line. So that's why horizontal line, the gradient is 0. So for a minimum point, the gradient is also a horizontal line. Okay, so the gradient of this tangent is a horizontal line. So that's why the gradient is 0. When it comes to inflection also, when we have this point, which is the inflection, the gradient is also 0 because it's flat here, it's horizontal here. And likewise, this one is the same. Okay, dy over dx is equal to 0. Okay, so all these are having dy over dx equal to 0. And let's continue. A stationary point can be a maximum point. Okay, maximum point, this one. Minimum point, this one. Or a point of inflections, which is this and this. Point of inflection happens to power 3 cubic equation. Power 3, yeah. So this one is more for power 2, quadratic. Of course, cubic also have maximum minimum, because cubic graph can be like this also, like this. Okay, I'll try to draw it. It can be like this cubic graph or like that. Okay, so two situations where we have also the maximum, minimum, maximum. So let's move on. Okay, now let's see maximum first. Maximum, you can see the dy dx is greater than 0 on the left. As you can see, the tangent is in this way. It's like going up, so the gradient is positive. So at this particular point, the gradient is 0, dy dx equal to 0. And after that point, the dy dx is less than 0. As you can see here, less than 0 because the gradient of tangent is going down. But for minimum point, the dy dx on the left is less than 0 because the tangent is going down. On the minimum point is equal to 0 because it's horizontal. And on the right is greater than 0 because it is going up. Okay, and now let's see inflection. So we have two kind of inflection. So you can see, for example, on the left we have dy dx more than 0 because the tangent is like going up. Then after that, at the point of inflection, dy dx equal to 0 because the tangent is horizontal. And on the right hand side of the inflection is more than 0 again. Okay, because it's going up. And for this case, less than 0, 0, then less than 0. So you can see different kind of changes. This is positive, 0, negative. This one negative, 0, positive. This one positive, 0, positive. This one negative, 0, negative. So different kind of change in the dy dx will lead to different kind of point. Okay, now let's see example. We look at part D. Determine the stationary point and their natures for each of the following curve. Okay, so let's see. This is a power 3. Power 3 cubic functions. Okay, so we want to do dy dx first. Dy over dx. So I differentiate straight away. 3 times 2, 6 x squared. 2 times 3 also 6x. 12x differentiate become 12. Okay, so after you do dy dx, now you have to let dy dx equal to 0. So 6x squared minus 6x minus 12 equal to 0. To solve this quadratic, it is good to divide by 6 first before we factorize. So whenever you can divide by any number, just go ahead first. And now I get the simplest form. The number is smaller now. It is easier to factorize. X minus 2, x plus 1 equal to 0. So then I can let each factor equal to 0. Then I get 2 x values, meaning that there are 2 stationary points. And after that, the question wants us to find the stationary point, so we need to find the x coordinate as well as the y coordinate. So to find the y coordinate, we have to use this equation, because this equation on the left is y, so you can put the x values here, here and here, then you can count and get the y. So let's say I call it equation 1. So I substitute 2 into equation 1, so I will get y equal to, okay, I substitute 2 here. I do some mental calculation. 2 times 2 cubed is 2 times 8, 16. Okay, so 16. Then now I put 2 here. 3 times 2 squared, that means 3 times 4, which is 12, minus 12. And then I put 2 here. So 12 times 2 is 24. Okay, then I have 16 for minus 20. Okay, then this is my stationary point. X is 2, y is negative 20. Okay, now I look at the second x value, which is minus 1. Minus 1, I substitute into equation 1 again. Okay, so I put here equation 1, y equal to, okay, so again I do some mental calculation. I substitute minus 1 here. Minus 1 cubed is negative 1. Negative 1 times 2 is negative 2. Then I substitute negative 1 here. Negative 1 squared is positive 1. Positive 1 times negative 3 is negative 3. And then I substitute negative 1 here, become positive 12. So at the end we get 7. So the point is minus 1 and 7. So these are the 2 stationary points. So beside that, they want us to determine their natures. Determine their nature means we have to determine whether they are maximum, they are minimum, or they are point of inflection. Okay, so how to do this? I will do it at the side here. Okay, so I will do it at the side here. We build a table. Okay, build a table. So x and dy dx. We want to see how the dy dx change. Okay, so I have 2 values of x here, which is minus 1 and 2. So I will start with minus 1 first, as minus 1 is the smaller one. Minus 1. So I will put a value which is a little bit smaller than minus 1. Let's say minus 1 point, okay, let's say just minus 2. Minus 2, 0. Okay, so what happened is, I know the x coordinate is minus 1. So I use minus 1. Then I want to check the gradient on the left of minus 1 and on the right of minus 1. So that's why I choose 2 values. I need 2 values basically. One is smaller, another one is bigger. Okay, so then after that, I'm going to consider the second x coordinate, which is 2. And again, I need to know the, beside 2, right, I need to know the x value which is on the left of 2. I choose 1, and then I choose 3 on the right of 2. Okay, so I want to see the plus minus of the dy dx. Okay, so we need to substitute all this value into this equation. Okay, so I'm going to use calculator to help out with this calculation. Okay, I substitute everything inside. So first I substitute -2. Okay, so hold on, need to 6. Okay. Okay, so I substitute everything into the quadratic just now. -6x minus 12. Okay, so first I substitute -2. I get 24. Of course, when you substitute -1, you get 0. We have counted just now. We substitute 0 into dy dx, we get -12. Then we substitute 1, we get negative. Let me check again. I substitute 1, I get -12 again. Now I substitute 2, I get 0. And then I substitute 3, I get 24. So what we see here is, you look at the notes at the same time when we look at this. Okay, so first we have more than 0. More than 0. This situation. More than 0. This is more than 0. Then we have equal to 0, which is this one. Okay, equal to 0. More than 0, equal to 0. I purposely draw like this because I want to show you the tangent. Equal to 0 is horizontal, and then less than 0. Less than 0 is going down. So you can see the graph to be like a maximum in the blue color part here. Maximum. So more than 0, equal to 0, less than 0, this is a maximum. Then we say that. So we say that. I write it. Okay, so I write it down here. Our point is -17 is a maximum point. Okay, now let's see the other side. So on the other side we have less than 0, equal to 0, more than 0. Less than 0, equal to 0, more than 0. It is this case. Minimum point. Okay, so we write down less than 0, equal to 0, more than 0. So less than 0, the graph is going down. Equal to 0 is flat. More than 0 is going up. So at the end, you can see it represents a minimum. And our coordinate is 2, -20. Then we say is a minimum point. Okay, so that is how we solve the question. Okay, now let's see one more example. We look at B. Y equal to x plus 2 cubed plus 4. X plus 2 cubed plus 4. Okay, now we have to do dy dx, differentiation. Dy over dx equal to, so I hope you still remember how to differentiate this. Let me write the formula here. If you have something with power, a bracket with power n, so the differentiation is n ax plus b, the power n move in front, and then the power become n minus 1. Then you still need to differentiate everything in the bracket. Ax become a, b becomes 0, so at the end only a remains. Then you will get na ax plus b n minus 1. So we have to use this formula to differentiate the bracket. Okay, so if I apply that formula, I will get 3x plus 2 square 1, and then differentiate 4 becomes 0. Okay, so of course, just for your information also, why I have 1, because I differentiate x and I get 1. Okay, differentiate 2, I get 0, so 1 plus 0, so end up with 1. So 1 times 3, then we'll get 3 x plus 2 square. So this is my dy dx. And then we let dy dx equal to 0. Okay, we let straight away lah. Okay, I let dy dx equal to 0 straight away. 3x plus 2 square equal to 0. Divide by 3. Bring the power 2 over, becomes square root. Square roots of 0 is still 0. So x equal to minus 2. So we get the x value, only one value. Then we find the y. I call this equation 1. Equation 1, we find the y. Substitute minus 2 inside. Minus 2 plus 2 cubed plus 4 will end up with 4. So I have minus 2, 4 as my stationary point. And we don't know it belongs to which situation. We have 1, 2, 3, 4. We have 4 situations. So we need to check the dy dx. Okay, so now since we have only one x value, so when I build the table, I can just build a small one. 3 values will be enough. I will put the x value that we found on the or in the middle, minus 2 in the middle. Then on the left, I put any value smaller than minus 2, like minus 3. This one minus 1. This is greater than minus 2. Okay, then I just key in everything into my dy in my calculator. So I'm going to substitute minus 3 into here, and then I count it. Okay, so 3, substitute with minus 3, so we get 3. Substitute with minus 2, of course we get 0. Substitute with minus 1, we get 3 again. Okay, now we look at our situation. First we get 3, positive, then 0, then positive again. So it belongs to this case, positive, 0 and positive. So because of that, this is positive, 0, positive. So it's like this, like that, and like that. So our graph is the graph that represents the inflection. The inflection, which is like that. Okay, so then we write it down. We said minus 2, 4 is a point of inflection. Okay, so just like that. Okay, now we have done the stationary point and inflection. Let's move on the next page. Okay, now let's see this. Question E. They said a farmer plants tomato on a plot of land with 80 tomato plants. Each plant produces 40 fruits. Okay, so again, we put it in this way. Tomato plants is 80. Then the fruits is going to be 40. Okay, now the question said, when the number of tomato plant is increased, then the number of fruit produced drop by 2 for every additional tomato plants. That means if this increased by 1, this one will decrease by 2. Okay, it's something like when this one is 80 plus 1, this is 40 minus 2. If this is 80 plus 2, then this is 40 minus 4. If this is 80 plus 3, this is 40 minus 6. So we can easily relate these two. We can easily relate these two in this way. Okay. if this is 80 plus x, this is going to be 40 minus 2x. So that is how we relate these two. Okay, we get the relationship first. So once we get this relationship, okay, then we can just do it like this. You have to understand that 80 tomato plants, each plant produces 40 fruits. That means one tomato plant produces 40 fruits. So if you have 80 tomato plants, so 80 times 40, you should get 3,200 fruits. 3,200. Okay, so in general, if you have this amount of tomato plants, so each tomato plant produce this amount of fruits, so the total number of fruits should be the multiple of that too. So y equal to 80 plus x, 40 minus 2x. So the y is the total number of fruits. Total number of fruits. Okay, so we can form the quadratic equation by using this way. Then y equal to, we expand it, 380 times 40. 80 times 40 is 3,200, and then followed by minus 160 plus 40 minus 120x minus 2x squared. So we can get the quadratic equation. And now what to do is, they said find the number of tomato plants. That means find 80 plus x basically, that yield the maximum number of fruit. Number of fruit must be maximum. Number of fruit must be maximum. So you want to find maximum, we already learned just now, we have to do dy dx, then we let it equal to 0. So we do dy dx minus 120 minus 4x. Okay, then I continue here. You let dy dx equal to 0. Then after that, minus 4x equal to 120. And then you get x equal to minus 30. X equal to minus 30. Okay, then after that, what we know is, how we know whether this is maximum. So if you still remember our technique just now, for our maximum, we have dy dx more than 0, equal to 0, and less than 0. So we have maximum, we have dy dx more than 0 first, dy dx more than 0, dy dx equal to 0, and dy dx less than 0. Okay, then it will be maximum. Okay, it will be maximum if this is the case. Okay, now of course, now let's check. Okay, we check. We want to double check whether this is maximum or not, or we find y first. Okay, find y first. We take this as equation 1. We find the y. 3200 minus 120 minus 30 minus 2 minus 30 square. Okay, so we count this, and okay, so we get 5,000. So that means 5,000 is the maximum number of fruits. So our stationary point is minus 30, 5,000. Okay, then after that, dy dx more than 0, equal to 0 and less than 0. Okay, let us double confirm whether this is maximum or not. Okay, so we just build a table x dy dx. Okay, now we try minus 30, and we try with two more value, minus 20, okay, smaller than it, minus 31, minus 29. Okay, we put into our dy dx, which is minus 120 minus 4x. So we key in and we try minus 4x. Okay, then we try minus 31. So I get 4. Then I substitute minus 30, I get 0. I substitute minus 29, I get minus 4. So as you can see, you get more than 0, equal to 0, and less than 0. Okay, so we get something like this. So that means this is a maximum. This is a maximum. So at the end, let's answer the question. So the question asks, find the number of tomato plants. So the number of tomato plants is 80 plus x. Our x is minus 30. Okay, so let's count it. Number of tomato plants equal to 80 plus x, which is equal to 80 minus 30, then which is equal to 50. Okay, so that is the answer. So we do it like this. That is how we handle the problem. Okay. Now I tell you one more method here. Okay, one more method. So from what we learned just now, we already understand something. We know that from y equal to fx, you do dy over dx equal to f prime of x. Then you do dy over dx equal to 0. Then you find x. Then after that, you use the x value found to find y. Okay, use the x value found to find y, and after that you get the stationary point. The xy is a stationary point. Okay, stationary point. Then I said you build a table. I build a table with 3x value. I build a table, and then you look at the dy dx to determine the nature. Determine the nature, where it can be maximum, minimum, this kind of inflection, or this kind of inflection. So I teach you another way where it will be faster because you can avoid table. Okay, so the other way is you do all this as usual until here you get a stationary point. You don't build a table, but instead of the table you do second derivative, d2y dx2. I do second derivative. Okay, so when you do second derivative, what happens is, if your second derivative, right, after you do second derivative, after you differentiate it for 2 times, then you substitute x value found into dy dx. into d2y dx2, the second derivative, into d2y dx2. Okay, then we have a few situations. If your d2y dx2 is less than 0, then it is maximum. If your d2y dx2 is more than 0, then it is minimum. Okay, so if your d2y dx2 equal to 0, then it is this one, inflection, or this one. So let us practice this way also. Let's practice this way, the blue color way. Let's practice this way also. Okay, because this way is quite fast also. Quite fast. So let's say example. I put one example for you again. Okay, let's say I use this number 3 as my example. So you do dy dx minus 6x squared, then you let dy dx equal to 0, then you get x squared equal to 0, x equal to 0. Okay, then you find y. So I call this equation 1. So you find y equal to 5. Then you get stationary 0.05. Now we don't want to build a table. We do second derivative. d2y dx2. Okay, so I differentiate the negative 6x squared. Then I get negative 12x. And then I substitute the x value that I get here, which is the 0. I substitute here. Okay, when x equal to 0, d2y dx2 equal to minus 12 times 0 equal to 0. When your second derivative is 0, then you can say that 0, 5 is a point of inflection. So we can do like this also. Okay? So this is an alternative, which is fast. You can see not much working. So we can easily get the point of inflection. But there is a problem. I have to remind you first. What kind of problem? If let's say your dy over dx need to use product rule and quotient rule, then most probably d2y dx2 you need to use product rule and quotient rule again for the second round, which will take a lot of time. So if that happens, right, you don't use this method. So that means if the dy dx involving product rule quotient rule, then d2y dx2 also involve product rule or quotient rule, most probably. Then it will be very hard to do it. Then you use this way. Okay, you use this way. This way, although we need a table, but better than doing second round of product rule and quotient rule. Okay, so each have its own advantages and disadvantages basically. Okay, so now let's see a little bit more, see what we have on the next page. More problem solving. So I will leave it to you, you can try it.